we're gonna get started. So this week we're doing not programming club. We are a programming club. We're doing Firebase. Uh, it's a very, very useful thing. We built our entire programming club website using it. I've made a couple projects using it. Blake has made a couple projects using it. I'm sure Nick has made a couple projects using it. Um, so what is Firebase? It's a suite of features provided for app development. It comes with a database, authentication, storage, web hosting, cloud functions, which is ways you can run stuff basically like if you need like server level features, like that says. And then this is the best part about Firebase, why it's super useful is there's a very nice free tier. There's a lot of stuff you can use before you have to actually start paying them money. So it's really good to just get a project up and going real quick, make sure like proof of concept, make sure it works. Or if you have like a small personal project that you just feel like you want to build like a quick website for, this will do it for you. And then it works website and then also iOS and Android. There's also a C++ API, and I think there's a Unity API, and there might even be, and I think there's a couple more than that too. So really useful. Their docs are super fantastic. So after this presentation, or whenever you're working on it, if you have questions about it, you can go to the docs and it'll probably answer the question you have. So we're going to start off with Firestore, which is their database system. So Firestore takes the approach of database differently than if you've ever worked with SQL, because it's not SQL at all. So instead of tables and then rows in the tables, you have collections, and then each collection has documents. So kind of higher order, you can think of collections like tables and documents like rows, but they're not really the same thing. Because documents, they're stored very similar to JSON files. And if you remember from the JavaScript presentation I gave, whenever that was, I talked about JavaScript objects, which is exactly what this is. So it's stored in key value pairs. So each document can have a different amount of keys with different types. So like one of them might have like a bunch of strings and then like an array or an object. And then a different one, if you don't have anything in the object, you can just not even have that field in there. And then you can also read live updates from the collection. So whenever a change is made, then it automatically updates, which is how on the website, when we have our next and live buttons, when on our end we click the button that says it to go live and sets it to start accepting attendance and stuff, when we click that button, it's using the snapshot feature to read it. It detects that change in Firestore and it updates the page automatically. And that's all without like doing any server code. It's just pure JavaScript. So here would be an example. So that line 1, you see we're accessing Firestore from the Firebase API. And then we would do collection. That would be the name of the collection because you can have as many collections as you want. And then right now we're getting every single collection in that document, and then we can do stuff with that document. You'll see there in my .then, I'm doing this weird thing with the parentheses and then that arrow and the brackets. That is another way to do functions in JavaScript. They don't create their own scope when doing it like this. And you'll see this throughout most of the rest of this presentation. It's a pretty clean way when you have functions that need callbacks to different functions. Instead of needing to define that function somewhere else or like putting the clunky function keyword in there, you can just define your function like that. So the parentheses is where you have your parameters, and then the arrow and then the brackets, that's where you'll start defining your function body. So here is an example of how you would do the same thing, except this is listening for the live snapshot. So it's basically the same thing, and then that dot for each will run the code inside of that do stuff for every single document in the collection. So like if you wanted to add every document to the table and then display the table, you would do it kind of like this. You do a snapshot, and then for each one you would like add the table row to something. This would be an example of how you add data. So here we're adding it as a JavaScript object with first name of John and last name of Smith. Right now, this one will be adding this document to the data collection with a Firestore generated ID for the collection or the document name. So that would just be like a random string of characters and numbers that is unique. If you wanted to specify that, you would do it like this. You would do collection and then .doc and the name of that document. So now instead of the ID being a bunch of random stuff, it would be Smith. And then same thing, you would do it like that. And then if you want to update a document, because this will always create a new document, or if that document exists, it will erase the document you have and add this new one. So update it, you would be the exact same thing. Instead of add, you do update. You need to specify the document, and then you just put in whatever fields you want to change. Those ones will change. The rest of them will stay the same. So functions, they're written in Node.js, which is still, it's basically it's like 100% JavaScript still, but it's written for the server. So you can do varying server things with it. So it's instead of using like PHP to do a bunch of stuff, you would use Node.js. You can trigger them when events occur in your Firebase project. So a good example, whenever a new document is defined and is created in a new collection, you can have a function occur. It'll be triggered. It'll run something based off of whatever document was created. Like one of my projects, whenever a new document gets created, I need to send that data to a different service I'm using. So that's what you could use that for. You can do it whenever files are created in the storage, and then do stuff with cloud storage. And then you can also just write a function that needs access to the higher level admin SDK, which I'm not really going to cover in this presentation, but if you need to look it up, you can. It allows you to like look up users and manage custom claims and stuff, which I'll explain a bit later. But you can call those functions by just hitting an HTTP endpoint with your website. So you would do a call, and then you would hit that, and then the cloud function would do stuff. Here's an example from one of Blake's projects. What this one does is whenever a new document is created, it's for a calendar thing he was working on. So whenever a new event would be added to his events collection, it remakes an ICS file so that you can like subscribe to the iCal link. So whenever a new one is created, the iCal has to update so people always have the most updated calendar. So that's an example of what you could do with functions. Authentication, this one is really nice. It has a built-in support for lots of sign-in types. So there's email and password. There's Google, like we use for the website, and obviously you can specify for different domains, or it can just be any Google account. Like for the website, you have to use your Trojans account. But then there's GitHub, Microsoft, Apple, Twitter, Game Center, the whole bunch of them. Phone number, I think you have to pay for that one, but and they're really easy to implement. Then it automatically will store all of your users in a separate location, and you don't need to like create like a users collection in Firestore unless you need to store more data, because the authentication users, it stores their unique identifier, their email, their password securely hashed, and I think like a display name. But if you need to store stuff like an address or phone numbers, that you can store in another collection and just reference like their UID or email if you had to. But it can be nice if you don't have to do super detailed stuff. You don't have to do any managing or writing your own logic for it. And then custom claims, you can give it so like, say you're making a thing like with a subscription, and people who subscribe, they get more features than people who haven't subscribed. If people have subscribed, then they would have like a subscriber custom claim. And then if you haven't, you wouldn't, and it can manage access like that. Or in the case of a different website where like there might be some users who have admin access that can do more with the website while everybody else just gets regular access, same thing. You can set their admin custom claim to be true. And then if that's true, when the website recognizes it, you can render different buttons and allow different functionalities. So here's an example of that, directly copy and pasted from our website. So here is how you would manage when the state changes of authentication. I'm doing that function thing again, so this will run basically as soon as the website loads, give or take a couple seconds. So then here, this function says, or if statement, if the user is defined, it will run this block of code that if on line 3 just checks to see if there's an active meeting. And then if there is, when you click on this on the link, or when you load this web page, it adds you to the attendance array. That line 7/8 is just how Firestore manages arrays to push a new user into attendance array. You have to do this weird union thing from a weird chaining thing, but it makes sure that's just how it works. So then if there isn't a defined user, then it prompts a sign in via redirect to the Google sign-in. Then we don't have to do anything after that. It'll handle this. Google, they'll sign you in. They'll redirect you back to our page. This time you'll have a user, and then this block of code will fire. Hosting, you can do serverless hosting. So if you just had like a static web page you needed to build for like a friend or something, we're not going to do anything with database. You can just put in some pure HTML and CSS and then let it go. You get a free URL. It'll be your project name.web.app. And then you also get a free SSL certificate from Let's Encrypt. So it's free, obviously, that's good. And then it'll be completely encrypted, handled by Google. You don't have to worry about like setting up the certificate and making sure it points to all of the right URLs and stuff. It'll just work. And then when you deploy a new feature, it doesn't have to take your website down and wait for like 5-10 minutes and then deploy it. You just run a command in the command line, it'll deploy it, and as soon as the new one is done, it just updates instantly. So you don't have to worry about anything like that either. And then I think this is the last thing I'm talking about before we get into the demo, is cloud storage. So you can use this to store files and documents. You can get public-facing URLs, and then there's also API calls, so you can dynamically get URLs as needed in your project. So that can be useful. That's like where Blake stores ICS files. You can store like user uploaded images there, stuff like that. So this is going to be a dumb app, but it'll kind of demonstrate how quickly this can get done. So it's just going to be a simple thing. There's going to be one input field in this form with one button. When you type a name in or thing into that button, it will then add it to a list of words, and it will automatically be live updating that on the website. So here are the basic steps that I'm about to go through. I'm going to go to their website, create a new project, and then I have to initialize Firestore from their web interface, and I have to initialize cloud storage from their web interface. If I'm using storage and want to set it up, I'm just going to do that. And then I have to initialize it locally on my computer so I can start development. So I already have the page up, so I'm just going to call it test. This down here is what the beginning part of your URL will be. So sometimes it can be hard to find something unique, but they make it very easy if you're going to continue working on your project to just buy a domain, link it up, and then you don't even have to worry about using their URL. You can just use your own. But since this isn't going to be a very cool app, I don't need to worry about it being unique, so we're just going to have that big ugly URL. And just go through this stuff, continue. If you haven't made any Firebase projects before, you'll probably have to make a new one. This is just for Google Analytics. So then let Firebase do its thing. This doesn't take that long. So pricing, obviously, you can go to firebase.google.com. I'm sure they have a very nice large button to tell you how much money they want from you if you pass the free tier. But it's very nice. I know for like Firestore reads, you get 50,000 of them a day. So it's pretty convenient because then you don't have to pay for anything. So we're going to go over here to Firestore. When you make a Firebase project, you'll also see real-time database. That's like their older database system. It still works. Firestore I think is easier to use. That's just what we've used for all of our projects. So I guess that's what I'd recommend. Right now, this is just asking how we want to start with our rules to who can access Firestore. I'm going to do test mode. So this is saying anybody can read or write if it's before next month. And then you'll have to pick one close to you. And then this will go through, make a Firestore thing for you. All right, so now we have our Firestore, and this is what the web interface looks like. So I could, go here, add a collection, and then it wants you to add a new document. So this would be an example of an automatically created ID, just a bunch of garbage. We can do name, and then you can pick a bunch of different data types. Nothing would be when it's empty, arrays, maps are objects, numbers, booleans, geopoints if you need that. So you could go and just add in stuff like this, like if you just had a collection, you knew what some of it would be defined, or for testing, just to get some quick dummy data in there before you have an interface for uploading. I'm not going to save that. Then we'll do a similar story here for storage. Already created, so that's nice. So then hosting, what you would do is go here, get started. It'll give you a bunch of stuff you have to do. You'll have to install the Firebase tools. I've already done that. And then you'll initialize it. You'll do Firebase login. Again, I've also already done that. And then you'll Firebase init. So first, I'm going to make a directory and then go into it. And then we'll Firebase init. This will take it a sec. And then we will do set up these. These are just, I'm just kind of setting them up by default. For what I'm about to do, we're not going to be using functions or storage, but I'm just going to do them. And then we're going to use an existing project. I don't remember what I called it. Just kidding. I think it was test. These, you could change the names. I'm just going to use all the defaults. I'm going to use JavaScript for this quick demo. You can use TypeScript, which I think we've talked about before. It's JavaScript, but you can use types. You could look into that more if you ever felt like it. It's pretty useful, very nice. I'm going to say yes, I suppose. I'll do this real quick. This is just going to be installing all of my node packages. You'll need npm installed for this. You can configure that however it works on Windows. I'm not entirely sure because I don't have it on Windows. Alright, so we'll do this. So then this prompt is asking if you want to allow redirects or if everything is going to be rewritten back to the same page. I'm going to click no. It just is kind of more useful for most projects, I feel like. This is a really nice feature. You could link it to a GitHub repository, and then whenever you push to, say, your master branch, it'll automatically deploy your new push. So then during development, you could push to a development branch just to have local changes still saved in GitHub. And then once your next release is done, you would merge them. We're not going to do that. More default options. All right, and now it is done. So I'm going to switch over to my VS Code window. It's going to think. I have to go to a different spot. And then I have to go here. We're going to open this. All right, so now it has created a bunch of stuff for us. We have our functions folder over here on the left with our node modules. This is the file where we would start writing functions code. We're not going to be doing that. Part of it is they made a change recently where to do functions, you need to have a billing account because they charge for build time of your functions. It's super cheap. I think if you spent a function building for several minutes, it would cost you 2 cents. So you would just set it up, you would do it. I haven't even been charged for that on any of my projects that I actually use functions for. So It's like basically negligible, but I'm not going to go through those steps for hopefully obvious reasons of payment information. And then this is an index file that has already been generated for us. So it has a bunch of stuff. It'll just kind of be a page that's like, hey, you got your hosting set up. Now like make a website. We don't need most of this code, so I'm going to begin deleting most of this code. We don't need any of this. We will not need this JavaScript because we will be adding our own. I notice I did leave this little bit here. This just makes sure that once the website is loaded, then the JavaScript will actually start firing. Then up here, never mind, they might have fixed that. Normally, Firestore doesn't show up, so you have to kind of just go change like analytics or something, or one that you're not going to be using into Firestore. I guess I don't have to do that today. So we're going to go back here. I put up some of the code I will be using just because watching me type HTML would probably make for a fairly boring meeting. Hopefully this copy and pastes like I want it to. No, we need that. Lost a body tag. All right. I just formatted everything. Okay, so now what we have here, we have a welcome heading tag. We have our super complicated form with a single input. And then we have our submit button down here. And then we will need to start adding our JavaScript. So I'm going to add this function right here. So what we have here, this is the function that will be triggered when this button is clicked. This is how we will add things from the form. So what it does, it gets the value of the form that we have with our ID of name. That's really important, using IDs when working with JavaScript so that it knows what items you're referencing. And then we do our db.collection. I need to add a quick reference to that because it doesn't actually know what Firestore or DB is. You have to define that yourself. So instead of DB here, I could do firebase.firestore.collection. But that's like a lot of annoying code, so I'm not going to do that. Then let's see what the next step is. We have this chunk. Yes, this chunk. So now we will be working with our snapshot. Man, that looks ugly. Okay. So what this function here that I just copied will do is whenever a new thing gets added to the database, like right here when we click our button and add in the name, it will re-trigger this on snapshot function. So I'm setting my rows to be nothing because that'll be the HTML I'll eventually be pushing to the page. And then we do our snapshot for each doc. You reference docs like this, doc.data, and then the fields in it, because there's some other fields with the doc, and then this data function just gets everything for you. So then we add our rows to it. We add a paragraph. I don't know why it's a paragraph. I think I'm using a table. Oh, I'm using a div. Okay. So we add the name as a paragraph to this div. So this will get updated every time it runs. It runs it for every single one of them. So I have to set it empty here because otherwise it would be duplicating it. So like if I added John, it'd be John. And then if I added Bill, it would be John, John, Bill. So you have to make sure it's empty when you set it. And then here we just set the HTML to what it'll be. That might be the last one. So I also in the presentation, I have everything I just put in here. So then if we wanted to deploy this, we'll open up our terminal here. We would just run Firebase deploy. Again, I am skipping functions. So if you ever need to not deploy stuff, you would just accept. This is still useful when you are using functions because you don't want to have to deploy your function every time and then build your function every time, because that means the deploy will take longer and you'll have to eventually pay a couple cents. And even though it's not a lot, you don't want it if you don't have to. So we'll just run this, hope I don't run into any errors, because we all know live demos when coding always work flawlessly. So this will just run through its steps, and there we have a deploy. Super nice. It gives me it'll give you your URL right down here. That'll open up in a new tab. It opened in a separate window, so I'm gonna have to put it over here. And here, look at this. We got a thing. So we deployed it that fast. And then if I add a bill to this and click submit, theoretically bill should have shown up there. It's a great question why he didn't. Let's look. What are console errors? There are no console errors. Oh, server load with status 404. That's a bummer. I'm gonna cheat. This is the one that I made to make sure it works. So obviously, since it's programming, you might run into some issues like this. I'm gonna redeploy this. I had it working, so I don't know why it wasn't. 404 errors are fun. So I'm gonna deploy it again and not do this. Make sure that our rules are all set up. Okay, yeah. And nothing can go wrong when you test it a million times. Alright, if this one doesn't work. There we go. I don't know what line of code I missed. I will find that later. But you can see as soon as I clicked submit, it loaded instantly. So Firebase is both fast and it's very fast. I mean, you obviously will have to wait some time for the network connections to hit from the user's browser app or whatever to Firebase. But once the connection is made, it's quite fast. I don't know how long this one will take, but so see that was fairly quick. Since I made it blank, it just added those. So in about 10 minutes, except for the part where I just copy and pasted all the code because I wrote it out earlier. Oh, this is the part I forgot. This is a very important part. This makes it so that when I click the button, the function actually triggers. So that's why it wasn't working. Good to know. But so Firebase, you can use it, make apps very fast. Website, jQuery could be useful. After winter break, we'll be teaching React eventually, which is the other thing we use to build our website. So with a combination of React and Firebase, you can make websites very fast as long as you kind of have an idea of what you want to do. So once, other than the part where we didn't really know how to use React and me and Nick weren't super experienced with Firebase yet, the website probably took us about a month, most of that being what we wanted it to look like and how it to be organized. So you can do it fast. You can get a really nice looking website that has very nice features. So yeah, with that, are there any questions? All right. So again, if you have any project ideas, speaking from experience, developing them as websites is a lot easier than using like C or C++, just because getting a graphical user interface is a lot harder and more complicated using languages like that. I mean, obviously it's possible, but you don't necessarily want to go through that hassle. websites, that part is just built in with HTML. If you don't know HTML, it's really easy to learn because it's like not even really a programming language. It's just like markup. You just add tags around what you want stuff to look like. CSS is a smidgen more complicated just because you never know how it will behave. But CSS, then HTML, you can add Firebase so you don't have to set up your own Apache and PHP servers or anything like that. It's either very cheap or free. Their payment plan, it can kind of get expensive fast, I think, because it moves on once you surpass all of the free stuff. Then it's pay as you go. So it's like, I don't know the numbers, but like say for every like 1,000 Firestore reads, it's like 5 cents, and then just goes up like that. I don't actually know that pricing. That's probably not right. So it's a payment model like that. So it's not monthly, which is another good thing about it. Is if you're first starting off with maybe like a random business idea or just a project that you want to make some side income on, if you start it with Firebase, you won't have any monthly costs, at least from Firebase, weighing you down. So when you don't have a lot of customers yet, it'll be free. And then once you start getting customers and getting that income, then you'll start being charged then. And you'll already have some income back and income from the free users. So very useful. Really encourage you to go look at the docs. If you have a project idea, just try to whip something out, because you never know what can come by you just randomly fiddling about making websites. So with that, I believe we'll call it a night unless there are any questions still. But yeah, so everybody have a good night.